So suppose we are given a circuit like this, and our objective is to find out current through each of the branches of this circuit. So the first step is we want to label the circuit, and then we want to give direction of the current, and third we will then fix a direction of a loop. So let us start. So first step is we will label the circuit. So let this be junction A, this is junction B, junction C, junction D, and then we have say junction E right here next to the battery. This is not exactly a junction, but we still put it as E so as to recall this later. So notice that E is not exactly a junction, but we have still labeled it. Now second step we want to do is that so first step is junction, and the second step is we want to allocate current. So let us start allocating current. So say if I1 is going out from here, so this I1 then splits into two parts. Say I2 goes here. So if I2 goes from A goes towards B, then from A to D we will just have left I1 minus I2. Now we have reached this junction. From D to E you have say current going on I3, and so since from this junction current coming in is I1 minus I2, going out is I3, so the remaining current here in this direction is I1 minus I2 minus I3, because no charge accumulates at D. Again we are using just Kirchoff's first law. Okay, so once you reach circuit C, we have to analyze the behavior, but in the meantime this current I3 goes here and this current I3 comes back here, because we are saying E is a junction and nothing is accumulating here. I3 comes back here. So I2 and I3 are going into B, so out of B what will come out is I2 plus I3 is what comes out of B. So there are two currents going into C. One is I2 plus I3, the other is I1 minus I2 minus I3. So the current going in this direction is just I1. Yeah, so you add up this and this, you get I1. So we have allocated current according to the first law of Kirchoff. So again, the first step we did is we labeled the diagram. The second step we did was that we applied the junction rule. That is the first Kirchoff law to allocate the current. And that means that current going into the junction is equal to the current coming out of the junction. So once we have labeled the diagram, you can see that this is correct. At every junction everything holds. Then we can start writing down the corresponding equations for each of the loops. Now we come down to the first loop, A, D, C, A. So let us mark this loop in the diagram. So say we are going in this direction, A, D, C, A. So let us just write this down now. So you have the battery first, 10 volt, out of which minus 4 I1 minus I2. So I1 does not encounter any resistance. So we are not talking about I1 first. So I1 does not encounter any resistance, so we don't worry about I1. The first resistance we encounter in this loop, ADCA, is the resistance 4. So we want to worry about 4 first. So you have minus 4 I1 minus I2. Yeah, so this I1 minus I2 is in the same direction as our loop. So you have the negative sign, the battery is the opposite sign. So battery is 10 and you subtract it. Then we go from D to C. From D to C again we have minus 2 I1 minus I2 minus I3. It's the same direction as our loop. So again this is going out from the battery. And then finally you have the same direction going from C to A. So you have this C to A going on C to A. So C to A is represented by this. So C to A, you have this 1 ohm of resistance. So you multiply 1 by I1. So you solve this and you get this equation as the resultant. Second we focus on is A, B, C, A. So this is the loop A, B, C, A. So we are saying we're going to A to B, then C, then A. So the battery here is 10 volt. Again 10, it is positive. So again in the loop, the battery is the positive, and if you are in the same direction as the loop, you have the negative sign for the current and positive for the battery. So the battery is positive. Then you first subtract minus 4 I2, that is the first resistance you encounter it in AB, so you get minus 4 I2. Then you encounter 2, again I2 plus I3, this direction is the same direction as the loop, so again a negative sign, so minus 2 I2 plus I3. Then you have minus I1, so this is minus I1, again the same direction as the loop, so 1 times I1. So we have covered the loop A, B, C, A. You add this up, you get I1 plus 6 I2 plus 2 I3 is equal to 10. Then we worry about the loop B, C, D, E, B, that is B, C, D, E, B. So this is the loop direction. So again the current is coming out from the positive side of the battery, and the positive side of the battery and the loop are in the same direction. So battery is positive. Then you subtract minus 2 I2 plus I3. Minus 2 I2 plus I3, again it's in the same direction of the loop. You're talking about BC, B to C, that is the direction of the loop. So you get minus 2 I2 plus I3, same direction as loop. Then notice that this direction, now we are in the part CD. In the part CD, we are saying the loop is going from C to D, but the current is flowing in the opposite direction. See, the current direction of the current, the arrow is in the opposite direction. Therefore, you have to put a plus sign in front of it. So now you have plus 2 I1 minus I2 minus I3. So this is equal to 0. And you rearrange this, you get 2 I1 minus 4 I2 minus 4 I3 is equal to minus 5. So we have 3 equations. You have equation 1, you have this equation 2, and you have this equation 3. So you solve these 3 equations. So you get I1 as 5 by 2, I2 is 5 by 8, and I3 is 15 by 8. Now you can plug this value into the system here and you get the required answer.